All right, so let's go over this vocab. So you should know the answer to this. What is it that defines two or more relationships for the same variables? It's two or more equations working together. What is that? What are we studying? More specific. Systems of equations, yes. A system of equations. All right. So I want to do this practice problem with you. We're probably just going to do one of them. Let's do B. Let's do B. So we're going to check to see whether the given ordered pair is a solution to this system. So remember, the solution to a system of equations is going to be the intersection, of the two lines, which can be represented by an ordered pair. Okay? So if we're given an ordered pair and we want to find out if it's a solution to this system of equations, what we need to do is plug in the x coordinate in for x and the y coordinate in for y, and see if the equation remains true. And we have to do that for both of the equations. So let's do that. So we've got y equals 15 minus 2x. My x coordinate is -4. My y coordinate is 23. So I'm going to plug in 23 for y, -4 for x. So I get 23 equals 15 minus 2 times -4. So now let's simplify. So that's just 23 on this side. All right. 15 minus 2 times -4. What part of this do we need to solve first, according to order of operations? Yeah, in the parentheses, but we can't simplify that any further. So what comes next? Multiplication. So we do 15 minus, and then what's 2 times -4? -8. -8. Now what happens? And I'm checking to see if this is true. What happens when we subtract a negative number? It turns positive. It turns into an addition problem. So what's 15 plus 8? 23. Is 23 equal to 23? Yeah. So that one is true. The -4, 23, is a solution to this first equation. Now let's check this second equation. Again, we're going to take our x coordinate and plug it in for x. Take our y coordinate and plug it in for y. So we get 23 equals 12 plus -4. We're checking to see if this is true. So 23 equals, what's 12 plus -4? 8. Is 23 equal to 8? No. So this -4, 23 is not a solution to this equation, to the second equation. Therefore, -4, 23 is not a solution to this system of equations. So this is not a solution. Okay, so all we need to do is just plug in the x coordinate for x, the y coordinate for y, for both of the equations. Okay. We're going to do more practice on this on Khan Academy later. But let's flip over to the next page, and we're going to work through this problem. So we have a real world situation where Edna and Maria are going camping, and Edna leaves the trailhead at dawn to hike 12 miles toward a lake. Maria is already at the lake, and she decides to meet Edna halfway. So she's leaving the lake the same time that Edna leaves the trailhead, and they're walking toward each other. Edna is walking uphill, so she's only walking 1.5 miles per hour, 1.5 miles per hour. Maria is walking downhill, so she's walking 2.5 miles per hour. So Maria is walking faster than Edna is walking. We want to find out when and where they're going to meet. So our first step is we need to define variables for time and distance from the trailhead. So our variables are going to be x and y. Which one of those is the independent variable? X, yeah, x. X is the independent variable. And then, so what's the dependent variable? Y. What did I tell you about time? So the two things we're talking about is time and distance. What did I tell you about time? Yeah, it's almost always going to be your x, your independent variable, because time just moves independently. We don't control it. So time will be our x, and distance then will be y. Okay. So let's write two equations now to model Edna's hike and Maria's hike. So for Edna, her distance is going to be dependent on two things. It's going to be dependent on her speed and on the amount of time that she walks. So what was Edna's speed? 1.5 miles per hour. So let's write this. So we have our distance, that's y. So her distance equals 1.5. So if she's walking 1.5 miles per hour, how far will she have walked after 1 hour? 1.5 miles. What about after 2 hours? How much would she have walked? 3. After 3 hours, how much would she have walked? 4.5. So what are we doing with the hours, with the amount of time she walked and the speed? What are we doing with those two things? They're increasing, yes, but what are we doing? You're taking the distance and you're doing something with the amount of time that she walked. Multiplying it. You're taking the distance or the speed, you're multiplying it by the time that she walked. So our equation is going to be y equals 1.5. That's our rate of change. We're going to multiply it by x, where x is the amount of time that she walked. So if she walked 1 hour, I'd get 1.5 times 1. If she walked 2 hours, I'd get 1.5 times 2, and so on. Okay, so now Maria, so Edna is starting at the trailhead. That's our 0, that's our starting point. But Maria is walking, she's starting 12 miles away from the trailhead. Whoops. She's starting 12 miles away from the trailhead. And she is walking toward Edna. So 12 is going to be our starting point. 12 is going to be our starting point. And then what else do we need to add to the equation? What else do we need to add? How fast is Maria going? 2.5. And how are we going to incorporate our x variable, the time variable, into this? What do we do with our x? Multiply it by what? Yeah, by the speed. Okay, and now we're going to take either an addition sign or a subtraction sign here. What do we think it's going to be? Why? Not because she's going downhill, but it is a subtraction sign. And it's because, so she's starting at 12 miles, and she's going to keep walking closer and closer and closer to the trailhead until she meets Edna, where Edna is starting at the trailhead and she's walking further and further away. So we're going to graph those two lines, and I think it'll make a little more sense once we see that. Okay. But first, we're going to solve this system by creating a table. So this is kind of like just what we just did, but a little more structured. So we have our time, that's our x variable, our independent variable. And then we have Maria's equation, which is y equals 12 minus 2.5x. And then we have Edna's equation, which is y equals 1.5x. So this is like our input-output table, where we take these different values for x, plug them into the equation, and see what comes out as our value for y. So we take 0 first. We're going to plug in 0 for x. So I'd get y equals 12 minus 2.5 times 0. What does that come out to be? You can use your calculator if you want, but I don't think you need to. Yeah, just 12. Because 2.5 times 0 is 0. 12 minus 0 is 12. Okay, so at their starting point, at the 0 hour, before they begin walking, Maria starts up 12 miles away from the trailhead. That's where she starts. Then after 1 hour, we get 12 minus 2.5 times 1. What does that equal? 12 minus 2.5 times 1. What's 2.5 times 1? 2.5. Now what's 12 minus 2.5? 9.5. Okay. So we know she's going 2.5 miles per hour, and she's starting 12 miles away from the trailhead and walking toward the trailhead. That means after walking for an hour, she'll be 9.5 miles from the trailhead. She'll be 2.5 miles closer. Now how about after 2 hours? Where's she going to be? Y equals 12 minus 2.5 times 2. There you go. 7. 2.5 times 2 is 5. 12 minus 5 is 7. Bless you. Bless you. Then we get y equals, for 3 hours, y equals 12 minus 2.5 times 3. Yeah, this one's 4.5. 4.5. So we just keep going down by down by 2.5. After 4 hours, we get y equals 12 minus 2.5 times 4. What does that give us? 2.5 times 4. What is 25 times 4? Yeah, 2.5 times 4 is 10. Yeah, 25 times 4 is 100. Think about quarters. 25, 25, 25, 25. That gives us 100. So 12 minus 2.5 times 4, that's 12 minus 10, which gives us 2. Okay, and then last one, y equals 12 minus 2.5 times 5. What does this give us? Minus 2.5 times 5. Negative 0.5. So what does that mean, negative? Why is it negative? She made it to the trailhead and then went a half mile past it. Huh? I can't hear you. Well, they met somewhere in the middle. We're going to figure that out. Okay. So, you guys think you can handle filling in this part of the table? Yes? We're going to be using this equation now. Still plugging in these same values for x. So I want you to do that on your own. Good. So, you don't have to write the whole equation. You can just write the answer if you want. Did anyone else already finish that part? Now, think about where and when did they meet?
Just how I like it. I mean,
Yeah. What time was it at? 3 hours. Now, let's go on to that side. And then we graph the two lines. So our x on the x-axis is our outdoors. And then we're going to scale that out. And up to 0 times 5. And then on our y-axis, we're going to plot the distance.
oh, so smart.
No. All right, you guys. So where and when did they meet? 3. What does number 3 mean? The time. The time. So after how many hours did they meet?
3.
3. And at what mile marker did they meet?
4.5.
There you go. Yeah. So now go on to the next page, and I want you to graph the two lines. Oh. Yeah, so graph the two lines. This is gonna be on the x-axis on here, and then these are gonna be on the y-axis. Okay, so we start by just scaling it out, and then plot the points.
So here's the time.
Yeah, so we already did
Comes to school.
Yeah, so now let's go on the next page and graph the lines. Start by scaling the x-axis and the y-axis. Yeah. And remember, time, the hours go along the x-axis, distance along the y-axis. Yeah. You're gonna
Snow a few days ago.
and just going it out, and just put that in your phone.
No, there was snow in the back.
Yeah.
Well, I still lost it.
Yeah.
I can't find it.
Yep, that's what I'm trying to see.
It's like a blue.
How do you lose that?
Because I'm stupid.
No debt.
There's just like these ones, like, it was blue, but I think it's crashed.
Oh, yeah.
Yeah, that one.
Or the little chubby.
Yeah, that one.
All right. Are you guys done graphing your equations? Okay.
Hiking time.
Hiking is what?
I think it's everything. Once they put it on